In this section, we will talk about an overview of statistics. We will define statistics, how to distinguish between a population and a sample, and between a parameter and a statistic. And we also will talk about how to distinguish between descriptive statistics and inferential statistics. So what is data? Data consists of information coming from observations, counts, measurements, or responses. These are examples of data. According to a survey, more than 7 in 10 Americans say a nursing career is a prestigious occupation. Social media consumes kids today as well, as more score their first social media accounts at an average age of 11.4 years old. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So we have data sets. You can have data that comes from a population or data that come from a sample. A population is the collection of all outcomes, responses, measurements, or counts that are of interest. And a sample is a subset or part of the population. Now, usually in the real world, it's impossible to collect data from everybody in the population. It depends on what the population is. And so what we do instead is we take a sample and we look at the sample to make inferences about the population. So in this example, it says in a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population and the sample. Describe the sample data. And they spelled this word wrong. I'm sorry. I want to correct that. There we go. I'm piggy like that. All right, so let's go ahead and describe the population. The population will be responses of all employees in the U.S. So, like I said, it's almost impossible to interview all employees in the U.S. So that's why we look at a sample. So the population will be responses of all employees in the U.S. The sample will be the responses of the people that they surveyed. So in this case, it would be the 834 employees in the survey. Okay, so they looked at 834 employees in the U.S. That's the sample, and this comes from all of the employees in the U.S. The sample is a subset of the responses of all employees in the U.S. Okay, so the data set consists of 517 yeses and 317 nos. And I got a little visual over here to the right. As you can see, the population will be all employees in the U.S. And then the subset or the sample that we took will be the responses that we got from the sample. Now let's talk about parameter and statistic. A parameter is a numerical description of a population characteristics. For example, the average age of all people in the U.S. A statistic is a numerical description of a sample characteristic. The average age of people from a sample of 3 states. Okay, so we know there's 50 states, but we only looked at 3 states. So we took a sample of 3. Whereas the average age of all people in the U.S., that's looking at everyone in the United States. So in this next problem, we're going to decide whether or not it's a parameter or a statistic. A survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. Okay, so we're looking at this. They said it's an average time spent is 50 hours per week, and it's based off a subset of the population because we only looked at several hundred collegiate student athletes. It doesn't say that we looked at all student athletes. Okay, so the average of 50 hours per week is based off a subset of the population. Okay, so therefore the average of 50 hours per week is considered a sample statistic. Right, let's look at the next example. The freshman class at a university has an average SAT math score of 514. Okay, so we're looking at the average SAT math score. So the average SAT math score of 514 is based off this time we're looking at the entire freshman class at this particular university. So the entire freshman class is being looked at. So in this case, the population is actually the entire freshman class. We didn't take a subset, we didn't take a sample of the freshman class. We looked at the entire freshman class and determined what the average SAT score is. So this would be a population parameter. In this next example, we're going to once again decide whether or not it's a population parameter or a sample statistic. In a random check of several hundred retail stores, the FDA found that 34% of the stores were not storing fish at the proper temperature. Okay, so if you look here, they took a random check of several hundred retail stores. It didn't say they looked at all retail stores. So this 34% is going to be based off a subset of the population. So therefore, it is a sample statistic. Now let's talk about branches of statistics. We have descriptive statistics, where that involves organizing, summarizing, and displaying data. So you'll see tables, charts, averages. That will be considered descriptive statistics. Inferential statistic uses sample data to draw conclusions about a population. So in these next examples, we're going to identify the population and the sample, and then we're going to determine which part of the study represents the descriptive branch of statistics and what conclusions might be drawn from the study using inferential statistics. A study of 2,560 U.S. adults found that of adults not using the internet, 23% of them are from households earning less than $30,000 annually. And I have the figure on the next page, so you'll see that. So let's identify the population. So we're looking at U.S. adults. So the population would be responses of all U.S. adults. So we know we can't interview all U.S. adults, so we're going to take a sample. And the sample will be the responses of the 2,560 U.S. adults in the study. So now we're going to see what part is the descriptive statistics. So in this case, the descriptive branch of statistics involves the statement 23% of the U.S. adults not using the internet are from households earning less than $30,000 annually. Okay, so they gave us some data here. And they summarized it. So basically, that would be the descriptive stats. So what inferences can we make from this descriptive statistic? So remember, we use a sample to draw inferences about the entire population. So a possible inference drawn from the study is that lower income households cannot afford access to the internet. Okay? Lower income households cannot afford access to the internet, which kind of makes sense because it tells you the 23 adults who don't use the internet, they have a very low household income, $30,000. So this is the visual over here. Okay? Let's look at this next example. A study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. Let's identify the population. Okay, so we're looking at Wall Street analysts. So the population would be high-tech, high-tech earnings forecast of all Wall Street analysts. Okay, high-tech earnings forecast of all Wall Street analysts. But this time we took a sample. So the sample we're going to look at is the forecast of the 300 Wall Street analysts in the study. So let's look at the descriptive statistics. It tells you the percentage of Wall Street analysts who incorrectly forecasted high-tech earnings in a recent year was 44%. Okay, so that's a large number. If you incorrectly forecasted and it's 44%, you're not very good at forecasting. So a possible inference drawn from the study is that the stock market is difficult to forecast, even for professionals. That's the end of this lecture.